Going live now.
You're introducing, aren't you?
Good afternoon, everybody, and welcome to our really exciting World Earth Day talk. Before we get started and I introduce you to our fantastic guests today, I'd love to hear which schools you're coming from. So in the Q&A chat box, if you can let us know your class name or your school name, and we can say good afternoon to some of you before we get started. We've got some schools coming in, so good afternoon, St. Stephen's Junior School. East Farley Primary is with us. Muirworth CP School Year 4 class, good afternoon. We've got Holy Trinity and St. John's Primary School. We've got Holt Farm Junior School. Murdashaw West Community Primary School. We've got Year 5 at Clifton upon Dunsmore Primary School. Wow, lots of schools coming through. The Walnut class, good afternoon. We've got St. Cecilia's Catholic Junior Schooler with us. The Dolphins class as well at Guston CE Primary School. Lots and lots of schools coming through. I hope you're all really excited for this great talk we have this afternoon. And what we'll do is we'll make sure that all these fantastic school names are popped into the chat so we can see how many different classes and how many different areas we're all coming from and joining together today. So I hope you're really excited. Again, happy World Earth Day. I'm going to introduce you now to a fantastic geologist. He is really exciting and just going to have a brilliant session this afternoon. So I'm introducing you to Sandy, who's going to tell us about the Earth story and your story. So take it away, Sandy. Good afternoon.
Thank you very much, Lydia. Well, it is so fantastic to be here live. Oh, no, live. Live? How do you know I'm alive? Well, because you can see me. And why are you alive? I can't see you, but I know that you've got a story to tell. We've got not a long time, but we are going to explore why are you alive? Why are you here? Why is the Earth here? Where did we come from? What's this all about? And of course, there are dinosaurs around. Now, we just got to watch out for dinosaurs. I'm very, very scared of dinosaurs. And if you see a dinosaur, you better just shout loudly, because even I need to hear it, because dinosaurs are around and I don't know where they come from. Okay, but we might get to dinosaurs. They want to be everywhere. But today we're going to talk about huge numbers. We're going to talk about the Earth. We're going to talk about rocks, and we're going to talk about fossils, and we're going to talk about you as well, and your story, because there are some strange stories to be told, aren't there? Yes, I know. Well, no, I'm not talking about you right now. We'll get to you just now. Okay. So we're going to start with massive numbers. Now, remember, I'm a geologist, which is why I wear a geology hat. This is formerly known as a geology hat. It keeps the sun off, and obviously hides my lunch underneath as well, because being a geologist is very difficult. I like music. What kind of music do I like? Rock music. Of course, it's rock music. It's got to be rock music. I'm a geologist. So we're going to start off with how old is the Earth around us? This is the first big number. Now, if you've got a piece of paper, or if your teacher could write it on the board, because that would be very useful, because it is a number that we're going to start with, and it is a massive number. Oh, is this inside out? Is this the wrong way around? Okay, I can see it. It is a number 4,500 million years. This is the beginning of our Earth and the beginning of your story. I want you to say it out loud. Are you ready? 4,500 500 million years ago. How about that? That is the age of the Earth, when it starts coming together, and it's a big ball of fire, and it's bubbling, and it's molding, and it's all lava, and there's no continents or anything like that. It's just horrible, gruesome place to be. Nothing can live on that. It is the worst place. It's like a really hot fire. It's hot oven. It's bubbling molten lava everywhere. It's a terrible place. But something miraculous begins to happen because it starts to dissipate. The moon has formed because a huge asteroid collides with the Earth and spins off, but it takes some of the Earth with it. So the moon is made of rock from the Earth. And when they collided, this massive collision, it starts to go in orbit around the Earth. So we've got the moon now. We've got this Earth slowly getting cooler and cooler until about 3,000. Our oldest rock is about 4,000 million years ago. And they're very strange rocks. They are green. They've got little speckles in them, but this green rock is very odd. We've got them in a few places around the world, but there's no life in them. The green tells us there's something special happening, that it's formed at the bottom of seas. It is like molten lava under the Earth, which we can now see in these ancient rocks. Then we get the next magic number. Are you ready for your next number? We've got our first number was 4,500 million years ago, right at the beginning of the Earth timeline. And we get our next number now, 3,500 million years ago. 3,000. What happens then? That is the beginning of life. We start to get something very strange. It is what we call a single-celled creature. So a little amoeba begins to appear, and it's just one cell, and they clump together and they form kind of algae. Now this is a piece of algae which is probably about 3,000 million years old, and it's called a stromatolite. You might be able to see some layers in it. It forms a layer, but you can imagine it on top of a pond. So if you think of a pond and it's got algae on top and it's all gone green and it's bubbling a little bit, well, that's what it would have looked like. It actually looks like a cow patch, but don't tell everyone about that, okay? I mean, you wouldn't, you probably wouldn't want to stand in it. And you get these stromatolites. They are very strange, these, because they are the earliest signs of life. But they do something amazing, because at that stage, the Earth, the atmosphere was toxic, which means it's poison. It's full of nitric oxide and carbon dioxide and horrible things that it couldn't breathe. But it does something really weird. Shall I tell you? You better not let the teachers listen. It farts oxygen. Sorry, am I allowed to say that? I'm not sure if I'm allowed to say that. Okay, I won't use the word fart. No, I just did. Sorry, mustn't say fart. Oh, I just did again. Sorry. Okay, I promise you I won't. I promise you I won't. I won't say fart. Oh, I just did again. What am I doing? Shh, Sandy. Okay, but it gives off oxygen. It pops oxygen. And it's this miraculous change that is taking place in the Earth atmosphere. And what is it? What? Ah, go away. I don't want dinosaurs. I do not want dinosaurs to come over there. We'll get to you dinosaurs just now, but not now. Dinosaurs haven't even begun to appear, so they mustn't come yet. Okay, so now we got these stromatolites and we got this algae, and they are eating food from all this poisonous gases, and they are creating oxygen. They are popping oxygen. Well, that's fantastic, because oxygen is very powerful. Oxygen has got much more energy in that oxygen than carbon dioxide or nitrogen, which is poison. And that happens over thousands and thousands and millions of years. So now we get to our next big time, next big date. So we've got 4,500 million years. Oh, I'm pointing at I've got a line behind me up here, and we have 4,500 million years. We've got 3,500 million years when life begins to appear. And then there's this huge empty space to 2,000 million years. We're at 2,000 million. That's the next date I want you to write down. 2,000 million years. That is when we start getting multicellular life. Now, what's the difference in multicellular life? Well, it's the difference between algae on a pond, where it's just little bits of algae holding together. Where was my stromatolite? So we've got stromatolites, and there's just algae holding together, joining together in clumps. Whereas multicellular life means that we can start to create bodies. You can start to create more complicated life. So we call it the beginning of complex life, 2,000 million years ago. And still nothing much happens because life is still very flat. There's nothing going. There's a little bit of multicellular life or complicated life, but not a lot. I don't know where all the life is. And we're looking around thinking, I don't know where the life is, but go away. You're not allowed to come yet. Oh, sorry, we do not want to. Dinosaurs are not there yet. Everyone just thinks about dinosaurs, but we haven't got to dinosaurs yet. Okay, so let's leave the dinosaurs. But we go through a long time, 3,000 million years, 2,000 million, 1,000 million years ago. Where's all the life? Nothing's happening. It's actually got a special name in geological. It's almost like the great empty period, because not much is happening on the earth. The continents are moving, things are changing, there are volcanoes, but there's no life. There are no trees, there's no plants, it's just algae on some of the water. But nothing. And then something miraculous happens. We call it the Cambrian Explosion of life, the Cambrian Explosion. And it happens at our next number, which is 580. 580. Now you're going to have to write this one. This is a very important one. Why? Because this is when proper life as we know it begins to appear. 508. What actually happens there? Well, I'm going to tell you something very strange. We get the weirdest creatures of all. How do we know this? Well, I'm going to have to introduce you to what fossils are like. Oh, I've got a great fossil. I'm going to show you what a fossil looks like. Well, firstly, here's a big rock I got from Morocco. So I was walking I was in Morocco, and I got them to split this rock open. Can you see it? Oh, it's quite heavy, big chunk, just round now, but they split it open, and it's about 500 million years old. So it's about that time. And they split it open, and there's this weird creature inside. It's bigger than my head. It's massive. So I've got one side which is like the inside of an egg, and that's like the outside of an egg. So they call positive and negative expressions of a fossil. But that's the way a fossil. It'll have one side which is an imprint, and one which is what the fossil actually looks like. So I'm going to pick that one up. So this is a trilobite, and were very important. If you went down to the seashore about 500 million years ago, this is after the Cambrian explosion, you'd have this type of weird creature swimming around in the sea. They were everywhere. But the weird thing is, they've got 17 legs. Do you know he had 5 eyes? They had very weird, I don't think they had he's and she's, they had very strange collection. They had noses all over the place. They were very strange, odd looking creatures. And they were the dominant, in other words, they were everywhere, from the north to the South Pole, to the west, to the east. These trilobites were the most successful. And they were around for millions of years. And had they continued, who knows? They might have evolved, and we might have grown up with 17 feet and legs and 5 eyes. Why? But we've got 2. So where did that come from? But something began to happen, and there was an event 375 million years ago. I'm going to tell you about a special creature. So this is our next big number, 375 million years ago. You're writing that one down? Because you're going to have to put them on a line sometime. I'm going to ask your teacher to get a ruler, and you're going to have to sit down with a piece of paper and put them on the correct places, the marks along that ruler. We're at 375. And that's a long way down the line. You can see behind. It's a long way down from 3,500. 370. What happened at 375? I'm going to introduce you to another creature which appeared. And this is one of my favorite ones. This is my favorite. It's my little friend, and it's called Tiktaalik. Now, the Tiktaalik is a very odd looking. It's like a fish, isn't it? It's a fish. It actually is. Oh, come on. It looks like a fish. It's got a tail similar to a fish, excepting it's that way. It's not that way. Almost like a little crocodile. Can you see him? Can you see him? And he made a very brave move, this Tiktaalik. It was a time of huge climate change. And he was caught in a pond on the edge of a sea, of a lake. And it was quite a dangerous lake. There were big animals, big fish in there. Because by this stage, it was not just the trilobites. There were animals in there with teeth and jaws the size of a basketball and massive teeth. And these little chaps were not going to survive long. So they were right at the margins, at the edges of the pond. And the Tiktaalik climbed out of the pond. And he had to escape the other fish. So he climbed out onto the land. Now, the land by this stage had some plants on it, and the insects had appeared. But this little chappie climbed out, and he became one of the early vertebrates on the land. Now, what do we mean by vertebrate? Well, if you feel on your back, can you feel behind you on your back? Can you feel your spine? Have you got bumps in the middle of your back? And you can feel in your neck. If you feel the back of your neck, can you feel bumps? That is your spine, because we call it a vertebra. So you've got the spine running down the middle of your back. This little chap has got a spine running down his back. That's odd. That's strange, because insects don't have that, you see. This is one, and the trilobites don't have it either. So he's got, also, very oddly, he had 4 legs. Now, insects have got 6 legs, arachnids got 8 legs, you got trilobites with 17 legs, spiders have got 8 eyes, some, you know, the insects, there are animals with all types, but the one who climbed out of the water had 2 eyes. He only had 2, or maybe she only had 2 eyes. And it had a spine. That's interesting. And how many legs has it got? Well, it's got 1, 2, 3, 4. It had 4 little legs, and it had what is very odd. It had the fossils which we find. It's got 5 fingers on the end, then lots of bones, then 2 bones, and 1 bone. Now that's important. If you hold up your hand in front of you, you'll find you got 5. Then you got a place here, our wrist, where you got lots of bones on your wrist, lots of bones. Then in this part, you've got 2 bones which work together, so you can turn your hand like that. And then you got 1 bone, and your leg has got the same. You got your 5 toes, you got your ankles, lots of bones, and you got 2 and then 1 bone, which is exactly what Tiki has got. Our Tiktaalik has got exactly the same. And because of that, Tiktaalik could do press-ups. How about that? He could do press-ups. The final thing, which is very interesting, the Tiktaalik had to learn to breathe in water and out of water. It had to make sure it couldn't take water in where it's breathing, its lungs, because it had a little pouch in here that it would use, as all fish do. There's got a pouch in there which allows it to fill with air, and the air would allow it to go up and down. And it converted that to use as a lung. That's interesting, because we have lungs. And what is important that we know that is that Tiktaalik used to hiccup. because of this connection between the breathing of air and water. You had to hiccup and stop you from taking water on board. Has anyone of you ever hiccuped? It's very strange. You can't stop it. Why do we hiccup? Do you know what? There's no reason to hiccup at all. We don't know why we do it, excepting that we are related to the Tiktaalik, who hiccuped to stop him from taking on board water. Which is why we know when we look at our bones, we look at how many legs and arms we've got, we look at our lungs, we look at our spine, and we look at how we breathe. We are probably related. You are probably looking at your great-great-great-grandfather. My grandfather will probably look similar to this, actually. My grandmother would definitely. But that is so important. This was a very important transition from the sea onto land. So that explains why you look like you do. Thank you, Mr. Tiktaalik. Right, where's our next one? We're going to move quite quickly on. Our next number is 251. This was the biggest mass extinction you've ever seen. What's an extinction? When a whole lot of species and animals disappear off the face of the earth because of an asteroid strike, because of volcanoes. It was the worst time. 251 million years ago was like a reset, and the trilobites disappear. A whole lot of creatures disappear, never to be seen again. One species, though, did very well. Now, I wonder if anyone can guess what they... Oh, okay. We'll get to you now. Okay. The one species which did very well were the dinosaurs. They appeared then. So after the big extinction event of 251 million years ago, we get... Yes, I know. You're still a bit dangerous, and I'm not sure I want you to come too close to me. Thank you. So we get these dinosaurs beginning to appear, and they dominate for millions of years. 200. So they start appearing after the big extinction of 251, and they are around for a long time till our next date. Where are we at? 66 million years. We're now at 66, and what happens is the dinosaurs disappear. Whew, I'm a bit worried about that dinosaur. You go away now. I'm tired of you. The dinosaurs disappear. Bye-bye, dinosaurs. Well, do they? One type of dinosaur didn't disappear, and we're not all that sure why. We need scientists to tell us why and answer these questions. The type of dinosaurs didn't disappear, and in fact, if you go outside today, you will see them in your garden. In your garden. Well, what are they? They are birds. Dinosaurs which had evolved feathers and a beak and perhaps could beginning to fly, they survived that extinction. So if you want to see a real life dinosaur, you go out into the garden, and then you go home to your dad and mum at home and you say, I've seen a dinosaur. And they'll say, no, the dinosaurs died out. How long ago? The dinosaurs, they'll say, disappeared 66 million years ago. And you say, no. Most of the dinosaurs did, but birds are real life dinosaurs. How cool is that? I love it. It's so cool. But something else happened 66. Not everything died out. There was a little creature which didn't die out. And this little creature was hardly the size of a mouse. It was a very strange looking creature indeed. It was a little mammal. It was warm-blooded, which meant dinosaurs were cold-blooded. But warm-blooded meant that it could live both in very cold climates and hot climates because it generated its own heat. It gave birth to live children. It's live young rather than laying eggs. And it could eat almost anything. I hope you all eat lots of things, because that's very important, because mammals are omnivorous. We can eat a whole lot. So this little chappie could eat meat, seeds, vegetables, everything it could eat, lots of different things. And this began the age of mammals. This continued now. The dinosaurs had gone, so mammals proliferated. And what are mammals? They are whales, they are horses, they are camels, they are elephants, they are tigers, they are dogs and cats. And then our next date is 2 million years ago. a certain kind of mammal appeared 2 million years ago, and this is where this chappie appeared. He's a wonderful chap. So our Homo Erectus appears. Now, he was very important. He appeared mainly in Africa, but he spread out quite quickly. He had quite a big, not a huge skull, but he had a big skull, but he had a big pointy out face. That was the beginning of our ancestors. This was our first ancestors of humans, as we say. So Homo erectus, that was 2 million years ago. And then 300,000 years ago, we're now into thousands. So 300,000 years, our last date, a certain other creature appeared. Where are we? Where are we? Come on. Come on. I'm going to fetch this one down. I'm going to fetch my friend down. This is Kevin. And Kevin is here. And yes, Kevin, and I'm coming to you now. Yeah, Kevin, I'm talking. Do you mind? So, Kevin, yes, we're going to tell them about you, indeed. So Kevin appeared, and Kevin is our ancestor. And yes, I know, Kevin. I'm going to tell them. So Kevin appeared, and he about 300,000 years ago, and now we proliferate across the earth. And that's why we have got. Yeah, I know. And that's why, Kevin, you look very strange. What happened to your eyes? I don't know. He's lost his eyes along the way. But he is very nice. And we've become a very successful creature. But in fact, we have got our ancestors, because we've got Tiktaalik. We've got our little mouse-like chappie from 66 million years ago. We've got Tiktaalik. We've got the stromatolites, which is all part of our big tree from where we have evolved. So what a story. That's why Kevin, in a sense, that's why Kevin's got 5 fingers and 4 hands and 4 limbs, got 2 legs and 2 feet now. And sometime we'll talk about perhaps how we evolved to become like that. So that's the story. I wonder if you've got any questions in our last 5 minutes. But I hope you've had fun and understand a bit more about what's happened to you and how you've ended up where you are. Yeah, that's the end, Kevin. Do we have any questions at all?
Yes, we do. That was absolutely brilliant, Santi. What a quick tour that was, but it definitely told us our story and the Earth story to celebrate Earth Day. So thank you so much. So let's have a look at some of our questions. Oh, this is a good one. How did the dinosaurs become extinct?
Oh, yes. So we had that date. Do you remember that you wrote down the date, the 66 million years? Something incredible, very scary occurred then, and that was when a meteorite, we think about 10 kilometers in diameter, hit the Earth near what is now Mexico. It hit the Earth, and it completely changed the atmosphere for decades, for hundreds of years. It created firestorms. It was a devastating event, this asteroid connecting with the Earth. There was also, at the same time, there were volcanoes taking place along India coast, and the atmosphere just went toxic. So it was mainly the asteroid, we think, which was the key event, which led to the extinction of the dinosaurs.
Excellent. We've got lots of questions coming through now. Just to let teachers know, before we take a couple more questions, we'll type in the Q&A box an email address, Ask an Ambassador. And if we have any questions that we don't manage to get to this afternoon, Sandy's fantastic and he'll answer some of those emails. So teachers, if you want to gather some of those questions and email them on, we can get an answer back to you. So let's have a look at some more. Why do we have different types of birds, and why did they develop wings? So I think it's thinking about our dinosaurs that we can see in our gardens.
That is a great question. It's only in the last 10-15 years that we've understood that the evolution of feathers was actually much more widespread than we imagine. We have found now feathers on fossils, dinosaurs in China. And we think that feathers seem to have evolved initially to keep you warm. So we actually think if we had to do walking with dinosaurs, I don't know whether any of you have seen the Jurassic Park films and things like that. If we had to do them now, almost certainly they would put feathers on the head and the body of the T-Rex even. Because what we're finding is that most dinosaurs evolved feathers, but we think initially for keeping warm, because feathers are wonderful to keep warm. Also as display. So you'll see birds, they show off like the peacock. Feathers would be great for display. You can puff them up and show off your feathers. And it was only later that it seems to have been adapted for flying. So it's a classic case in evolution. It doesn't suddenly evolve flying from feathers. It takes something which has evolved for a different reason, a different purpose, and it adapts it. So feathers involved initially to keep warm, then they use them for display, and now they use them for flying. And because the petrosaurs and all the other flying kind of creatures disappeared, the flying dinosaurs disappeared at 66 million years ago, birds flourished. And that's why we got such a variety of different types of birds. For every climate, you will find birds, from penguins in the South Pole to huge birds, the ostriches, the non-flying, to the little ones, the big ones. Birds have evolved because now you've got no dinosaurs or other bigger birds to stop them.
Excellent. This is a lovely question. How did you learn all these facts, Sandy?
Oh, my brain is just falling over. I've been doing this I've been a geologist for 40 years. I started looking for gold. You see, I've actually brought a bit of gold with me. So wow. I carry gold. So this is what I started with. So I'm a gold prospector by training. But actually, the earth is way more interesting than just gold. So I spend a lot of time with water, and I love going into schools and taking all my rocks. It's just from engaging with the earth and asking these brilliant questions, and you will learn. And that's all I do, is ask questions. I wish I knew all the answers, but I just love asking the questions. Keep Amazing. Asking questions.
And maybe we can wrap up with this question. We've got so many questions come through. So just to remind teachers that to use that email address, and we can get Sandy to answer some of the questions afterwards. But we can see, even through your talk and in your background, Sandy, that you have lots of models and skulls and fossils. One school would like to know, how many do you have?
Oh, do you know what? Every time whenever we move a house, or whenever I have to move, my wife says, you got to get rid of some of your rocks. I can't bear to get rid of them. I've got so many rocks. My garden is full of rocks because I travel around the world so much, and I collect rocks everywhere we go. And I'll tell you a secret, it doesn't cost anything. You don't have to pay for a tourist. You don't have to buy them. You just look at the earth around you and pick up something which takes your attention. That's the key with this, is just look around you, engage with the earth. You will always find a rock. I bet you most of you at home have got a special rock under your bed or on your table or somewhere. And if you haven't, you've got to get one, because rocks tell us a secret about not just the earth, but a secret about us as well.
That's brilliant. Sandy, thank you so much for this amazing Earth story and for telling us our story and the history, and what a great way to celebrate World Earth Day. Thank you to all the schools who've joined us this afternoon. I am amazed by all the schools that are with us and all the fantastic questions that you've had. So teachers, please do use that email address. And this talk will be available on our website as well afterwards, if you want to go back and work on your timeline and have a little think about all the amazing things we've learned this afternoon. So thank you everyone for joining us. Sandy, again, thank you so much, and have a great Earth Day, everybody. Take care. Bye.
Great Earth Day. Bye-bye. Bye.